Hello, everyone. Thank you for joining us at Cribble today for our webinar. Today, we will deep dive on best practices for investigating security breaches and show how our data collection feature helps you conduct better investigations. We will have a demo during the course of this event. During the webinar, we encourage you to ask questions using the Q&A button at the bottom of the console. We have time at the end of the presentation to answer all of your questions. We will be recording today's webinar and we'll send a link to the recording when it becomes available. So please check the email account that you used to register. For information on upcoming events, please check out cribble.io/events. Our speaker today is Cribble's technical evangelist, Steve Littris. Thank you again for joining us today. Steve, I will now turn over the presentation to you.
All right, thanks, Brian. Hi, everybody. How you doing? I guess I shouldn't ask questions when you guys can't answer. We'll start out with just a little intro. I'm Steve Littris. I've got over 20 years of IT experience. I've been a developer. I've been a sysadmin. I've done bits of security work here and there. I've also run applications teams as well as infrastructure teams. I've been architecture. I've done architecture and run architecture teams as well. Now, back in 2006, I was actually running a lab that was supporting an enterprise apps development team, about 300 people, from configuration folks to developers. And every day it was just kind of a nonstop slog of, hey, this is broken, hey, this is broken. And I could never get ahead of it. I happened across, browsing the web, I happened across an ad for a little company called Splunk that sold itself as a super grep. I grabbed it, installed it, started feeding my logs to it, and all of a sudden I could come in the morning, look for errors and fix them before anybody saw them. I went from being kind of the guy everybody beat up to the rock star. At that moment, the power of logs totally compelled me. And I've been kind of espousing using log data to help solve problems ever since. About late last year, I was a prospective Cribble customer. And I was so impressed with the product and so impressed with the people that when I started to decide it was time for me to move on and find my next chapter, Cribble was one of two places that I was really, really excited about potentially going to. So when I joined the company in March as the lead evangelist, I was really excited to be here, and I'm still super excited to be here. Now, of course, as an evangelist, my main job would be going and speaking at conferences, but since travel for conferences isn't really a thing anymore, at least not for now, I've been doing most of my evangelization through the written word in blogs and white papers and such. So I'm really excited to be talking to you guys today and actually get to talk. So let's start out with an incident. Let's say your SIM picks up notices something, sets an alert, becomes a ticket, and that ticket gets assigned to a security engineer. She starts her investigation and quickly decides she needs to start looking at logs. And as she's going through the log system, she realizes that this is not just an isolated incident, that there's more to it, that it looks like it's been going on for a long time, that it could be wider spread than she thought. So she starts working back through the data available in the log system, looking for the beginning of this problem. And very quickly, she reaches the limits of what is in her log system. There's just no more data, no earlier data. But really no problem. They archive data, they keep it off on nearline storage or whatever. So she reaches out to her colleague in the log system team, if you will, log management team, and asks him to restore the data. Now, they keep them in bucket archives. So it's, if you're going to restore a bucket, you got to restore the whole bucket. And he clearly doesn't want to restore everything that they have because that's just going to take too long. It's going to take up too many resources. And it's just going to be a problem. So they agree that he'll just restore a month's worth of data. So he goes back to the archive, maybe to tape, maybe to local store, maybe to nearline storage. And once he finds the data, he loads it up into the log system. A couple hours later, because that's how long this stuff takes, she's back in business and she's looking through the logs again, still working her way backwards. But she runs into the same problem again. She gets to the beginning of that month worth of data, still hasn't found the beginning of the issue. So she has to repeat the cycle. Fast forward, it's a couple more hours. She's back in business. She goes through the process again, once again, figures out that the event happened before the data she has. So she goes back yet another time, only to find out that there's no more data available. So she's faced with an incident now that she's pretty convinced is part of a bigger problem. It's looking like a breach, but she has no way of telling when it started yet. And because of that, she has no real way of getting a full idea of the scope of the incident, how many people were involved, how many other systems it impacted, et cetera. It's a fairly big problem. So there are really two problems that I see in that. There are two areas, I guess. Data retention. You need to have the data available to be able to do the investigation. And really, no matter what your policy is, there's no guarantee you're going to have all the data that you need to investigate an issue. And time. And when I'm talking about time here, it's the time that it takes to do these investigations and the roadblocks that come up in these investigations. We'll talk a little bit about each of them. So going to data retention, data retention is effectively an insurance policy. You're balancing risk, the amount of risk you're willing to take versus the amount of cost you're willing to incur to try and mitigate that risk. When you get yourself car insurance or homeowners insurance, when you decide exactly what your policy looks like, for the most part, it's a balance between how much you're willing or able to pay on a monthly basis or for the policy itself versus how much you can afford to go out of pocket when a problem comes, so your deductible. Data retention, no different. It's a balance of cost of mitigating risk versus the risk you're willing to take. If your company is willing to incur a lot of risk, then the cost can be fairly small. But most companies want to be a little more balanced than that. Retaining your data in the log system is really expensive. And it's really because the infrastructure required has to be fairly high performant. When you are on a logging system, you're generally using disk that's at least good at random access, like database type disks. So you're probably using SSDs, et cetera. Those systems they're really optimized for these big needle in the haystack searches. They're not optimized for just being seas of data. So it's really expensive to retain all that data within the log system. And like I mentioned in the example, it's also really slow to get it back. It's hard to get data back into it once you've sent it out. Luckily, the last 10 years have really produced a number of great alternatives for archive storage, from object storage, whether in the cloud or on premise, to inexpensive archive disks, et cetera. The approach is really ripe for change at this point. So we're going to talk through an example of that change. I'm going to use a kind of a made-up company that ingests about 1 terabyte a day. For this example, I'm going to use AWS because they have a published price list that's easy to get at, and it also helps do apples to apples comparisons. The same factors are going to play if you're on premises as well. So, there are economic factors that will drive down the cost there as well. They're just harder to model because every site has different technology. Every company has different discounts. So being able to model that stuff with all the variables is very difficult. So we're going to use AWS for the purpose of this. So if we have a log system that's running, maybe we'll use 3 for now, 3 EC2 instances. If you're not familiar with AWS, an EC2 instance is effectively a VM. M5s is a type of instance. And you're storing your data on these GP2 volumes, these EBS, Elastic Block Store volumes. GP2 is the type of EBS volume, and it's the low end of their SSD offering. They have cheaper storage, which is, which is not necessarily very good for random access. So it's not really appropriate in a log store. But if you're retaining all the data in these GP2 volumes, they run about 10 cents a gig per month. So if you're doing 1 terabyte of log data a day, and you're trying to keep 30 days of data around, That's effectively 30 terabytes. You're keeping a rolling window of those 30 days or 30 terabytes. That's going to cost you about $3,000 a month, which extrapolates out to 36 grand a year. But let's be honest, I've yet to see a company where 30 days worth of data retention is enough. So you extrapolate that out. And when we look at 6 months, we're getting up in pretty significant numbers, 216 grand a year. If you move up to a year, which I think is at least table stakes for the most part, you're getting shockingly close to $500,000. That's a lot of money. And especially when we think about the fact that we hear all the time stats about the data that's in people's logging systems that a really high percentage, like in the 90s, is never actually searched against. It's really just there for retention's sake. It's a lot of money for just that. So let's look at an example where we've taken the same example and we've pulled in archive storage. We still have the same instances. We still have EBS GP2 volumes, but they're much smaller because really in an archive model, you're only keeping the running set or the active set of data, whatever your team actually needs to be able to do their day-to-day analysis. For the purposes of this, we're going to say that's 30 days. So we're keeping that 30 days worth of data in the GP2 volumes. But we're adding two new sets of services, I guess I should say. In this case, AWS S3 and Glacier. We're only going to be looking at one variant of S3, and that's standard. There are multiple variants. We could have multiple price points listed here, but for the purpose of this, we're just going to look at one of them. And then we're going to look at two parts of the product line for AWS Glacier. Now, when we do this, I just modeled it out for 12 months. Just look at the cost for S3 versus that cost for GP2 for 12 months. You go from $432,000 a year to $97,000 a year, and this is all list price. Now with just moving to S3 for my archival, I could actually save, if I have that $432,000 in my budget, I could now retain 4 years of data or more than 4 years of data, where before I was limited to my 1 year. When you move down to Glacier, Glacier's significantly cheaper because the retrieval time is a bit longer. So now we're paying about 20% the cost of even the S3. And if you move into Deep Archive, which even has longer retrieval times, you get down to $5,000 a year, under $5,000 a year, which is kind of ridiculous. I said that S3 would give you 4 years of data, but if you take that Deep Archive number, that's like 96 years of data. Obviously, that's ridiculous, but most companies will blend these. S3 has a nice feature where you can do a life cycle policy where you can say, for the first 3 months, keep it in S3. And then because I'm much less likely to have to retrieve data after 3 months, let's put the next 3 months in Glacier. And, I almost never pull data after 6 months. So let's put the rest in Deep Archive. And you get a blend, which brings down your cost even more. There are caveats. Like I said, each one of these has a different retrieval time. S3 is pretty much instant. Glacier has a bit of a delay, and Deep Archive has a significant delay. So you have to model out how often you're going to need to pull that data and how time critical it'll be when you do, and then put it in the right place that is the most affordable place that still meets your needs. Another thing to think about with the idea of a year's worth of retention, back in 2008, the Ponemon Institute published a study that I think they did it at the behest of IBM that determined that the average time from breach occurrence to breach detection is 197 days. Now, obviously, that varies based on industry, what kind of investment you've made in your security team, how good your tools are, how good your people are, all that stuff. But 197 days is, over half a year. Most companies really absolutely have to have the bare minimum of a year's worth of data. That's why I say I think that's table stakes. But there have been a number of really, really high profile breaches in the last couple of years that have taken much longer. For example, the Marriott breach that everybody heard about, I want to say it was last year or the year before. That took 4 years to detect once it happened. And another one, Dominion National, took 9 years. So the more data you can keep, the better. If you can keep 4 years, if you can keep 9 years, and still be able to afford it, you're in much better shape. Time is also a really big problem. When I'm talking about time here, I'm really talking about the time for investigation, the time that it takes you to actually be able to detect and go figure out the scope of the issue. Most of you are probably familiar with GDPR, the General Data Protection Regulation in the EU. But one of its tenets is that is this line right in here, that if you do have a breach, you have to notify no later than 72 hours after becoming aware of it. That is not a lot of time, and especially if you look at the example where we're going back and talking to the logging engineer, and he's having to go back and pull data. And every interaction there is about a 3-hour interaction. 72 hours is 3 days. People got to sleep. And if you're going through that cycle constantly, you're going to have a real hard time meeting this on a bigger breach. Again, the other part about that is that if you notify without knowing the full scope of the breach, you're effectively telling your customers, every one of you could possibly be impacted by this breach. And even if it turns out later that they weren't, that's going to do a lot of damage to their confidence in you as a company. They're going to wonder if you can actually manage their data because you couldn't even tell them if they were impacted or not. However, GDPR is not the outlier. Nearly every country now has a privacy law of some sort. And even US states are starting to get in the mix, with California putting CCPA into law, or I guess into effect this year. New York has SHIELD. None of those, as far as I know, have a breach notification window like GDPR does. But I expect we'll see more of that over time. I expect we'll see those rules get more and more restrictive for the data controllers, if you will. Now, on top of all that, your company may have an internal SLA around investigation that you're still going to need to meet. So if you factor all these things together, streamlining investigations is an incredibly important piece. But the other thing about streamlining them is that no company that I know of, unless they are emergency services, optimizes for emergencies. They build their organization to do their day jobs, to ship their software, to sell their widgets, to whatever that company does. So that means that when an emergency happens, it's not going to be the most efficiently managed thing. You're going to have to overcome organizational inefficiency. And this plays out when we think about that example, where if our security engineer has to go to the logging engineer and ask for something, he may be in the middle of something else. He may have other priorities. It's easy to say that security trumps all. In reality, it's not that easy to do across a company. So, other departments have their own agendas. They have their own priorities. And if he ends up in the middle of something else that he can't break away from for 4 or 5 hours, that's a lot of time lost. And then when you start thinking about like stacking that on top of each other, if he has to go to tape for it, he probably has to pull in somebody from the backup or storage team to actually pull the tape. And if those tapes are off-site and have to be pulled back from somewhere like Iron Mountain, forget about it. And the whole timeline is just going through the roof. So let's revisit our example. Let's say that about a year ago, our example company decided to get rid of the archive approach and replace it with our object store, our affordable archive approach. This has given them now gone from a couple months worth of data retained to a year. But unfortunately, which is great for the investigation because she's going to have a lot more data available to her. But she's still hampered by this organizational issue, by the fact that she has to go to somebody else for it. Now, if he can actually get the data back faster, but it's still a delay. It's still friction in the process. So what if we could actually get rid of that and give her the ability to go to the archive and get the data herself? And moreover, what if we gave her the ability not just to pull like an entire bucket, a month's worth of data, but to be surgical about how she gets that data out? If she's looking at a specific system or a specific IP address or set of IP addresses, if she can just filter based on that and only pull the data she needs back as she needs it, it's going to streamline her process. And moreover, as that investigation grows out, she's going to probably see other things she needs. And if she's got the access to go pull that data, she can get it as she needs it. And it's going to streamline her environment, or it's going to streamline her process. But it's also going to eliminate a lot of stress and frustration on her part and make this whole thing work a lot smoother. I do believe that self-service is kind of the killer app for organizational, not dysfunction, but inefficiency. If you can keep the organization out of the way of people needing to do their jobs, you've won. There are open source tools you can use to do exactly this. And in fact, in the resources that you guys will get with the replay, or the resource links you'll get with the replay, there is a link in there for a blog post by our CEO, Clint Sharp, about building what we call an observability pipeline via open source tools. But at Cribble, we believe that our product, Logstream, is best in class for doing exactly that. It makes it easy to create that kind of pipeline, and we'll talk a little bit about what that pipeline is. So if you're confused about it, hold on a second. But we also believe it makes it easier to implement exactly this kind of scenario with self-service as of our most latest release. So just talking about the product a little bit. When we say observability pipeline, we're really thinking along the lines of kind of a big data pipeline where data comes in, it gets transformed along the way, it gets loaded into different systems. You may create data marts, et cetera. It's a very similar approach. We tend to shy away from calling it ETL for logs, but fundamentally that's what it's doing. And the reason we shy away from that is we're not a general purpose ETL tool. So we don't want to send that message. But in this kind of observability pipeline, I guess, area or category, we can ingest data from all of these sources on the left. And this is just a small list. The number of sources that we can ingest from changes or just growing, I guess I should say, as we rev our product on a regular basis. But we can take data from any of those sources, feed it into Logstream. And we can use our routes and pipelines to process that data, maybe clean it up. A lot of logs are incredibly chatty. We can enrich that data with things like geo-IP lookup of IP addresses in the data. We can then secure it. We can do things like encrypt the data, mask it, redact it, et cetera. And then we can route it to any of these destinations. And when I say any of these destinations, it's not a one destination. We could route certain things to Splunk. We could route other things to InfluxDB. We could route our metrics to InfluxDB. We could route logs to Splunk. We can vary that up as we see fit. It's very flexible. And by putting Logstream in the middle of your log environment, you actually build a lot of flexibility into it. So when we look at this, if you're using the archived approach, the only things you're going to want to keep in your index log store is, again, what I'm calling the active set, the things that your technicians and engineers and whatnot need to be able to access on a day-to-day basis. The rest of that stuff doesn't need to go in there. So we have one pipeline that's actually doing exactly that, sending just the stuff you want to analyze now to index storage. But you also have a bunch of logs that you probably don't really need to analyze, but you might want to grab metrics off them. You might want to pull values out of the logs, aggregate them, and send them to a time series database. And by doing this, you can drastically reduce the amount of data you're ingesting. We've seen 1,000 to 1 where a gig coming in might equal a meg going out. great examples of logs that are rife for this are things like VPC flow logs, right? Super chatty, not very useful until you need them. They're not something you're going to go do a whole lot of searching against, probably. They're probably more likely needed for an investigation, but you may want to pull metrics off them. You may want to actually see, certain flow, destination, and sources. You may want to create metrics on that. So why not do that within the pipeline, and then feed it to a time series database while you're saving off that data for later. And speaking of saving off that data for later, the archival pipeline that we see in here is the pipeline that actually drives the whole self-service mechanism I just talked about. You can archive data to this object store at any point in the process, and it all depends on your policy and what you want to do. You can do it before any data gets changed, so it's as close to the raw log as possible. You could also do it at any point in time while it's being enriched, while it's being cleaned, any of that. So it's totally up to you how you use that data store. But by putting that data in putting all your data in the data store, and then just putting the specific stuff you need in the other systems, you can discard everything else, and you're not carrying around that whole weight of all that data in your backend infrastructure. That's only half the process, right? That's writing the data to an archival store, if you will. But until 2.2 of Logstream, our version 2.2, which came out a couple months ago, we didn't really have an easy way of getting it back in. But we rolled out data collection. It's batch processing for logs. And by adding this in, now we have a really easy way to get data back into the system. And not only getting data back into the system, but filtering it based on values that are stored as the data is stored. So partitioning scheme information. We can replay data from storage for investigations later, as I kind of talked about in the example. But the thing I like the most, when I was running log systems, if I had to go back and pull data, I really didn't want it to take up, I didn't want it to basically pollute my existing system. I didn't want to deal with the performance repercussions of additional data on the back end. And I didn't want to have to go deal with getting rid of it after the fact. One of the things I really like about this is that if I'm spinning up an investigation, why not spin up a completely ephemeral log system for that investigation? A completely empty version of Splunk Cloud, Elasticsearch Cloud, or AWS's Elasticsearch. Why not spin one of those up and just load it? So that for my investigation, I just have the data I want for it. I'm not working around other people. I'm not impacting them performance-wise. It's all about my ability to do my investigation. So that actually brings us to demo. So the demo scenario that I have here is an S3 bucket with about 6 months of firewall logs in it. I've got a Logstream environment. Oh, and a note on those firewall logs, they're all generated. There's no sensitive data in them, so I'm not worried about anybody seeing them. I've got a Logstream environment that I'm running, and I have an empty Splunk instance. So let's actually jump over to those systems right now. And I'm going to show you a little bit real quick. I'm not going to do a full demo of Logstream. I'm going to focus on data collection, but there are a couple, for people who haven't seen it before, there are a couple concepts that I should really cover first. So this is our product, and I'm going to go into one of my worker groups. A worker group is just a group of instances that you're running for Cribble around a specific set of use cases, whether that be routes, pipelines, or whatever. In this worker group, I'm at the routes side, and when data comes in through any of our sources, we're really dealing with events that are coming in. Those events go through this route tree, or route list, top to bottom. So think it's very similar to how network ACLs or firewall rules work, right? It's kind of a top-down approach. The things will go through, and if it matches, it may get shifted off. It may actually go through a different process, or it may continue to go. And the same is true about our routes. You'll notice there's a route name, there's a filter expression, which we'll talk about a little bit more as I go through the demo. But this is basically a JavaScript expression that allows you to decide, that gives you the ability to decide what data goes into this route and what data does not. Each route has a pipeline that it goes through, and I'm going to get to pipelines in just a, actually, I'm going to get to pipelines right now. Pipelines are where we do modification of data, where we do any of the functions that we have for data manipulation, cleanup, GeoIP, lookups, any of that stuff is done here. You see I have a list of pipelines in here. Some of them have routes, some of them have route input, some of them don't. If you see none and none, they're just not used at all. But they're great for actually, being able to go back and look at how to do these things. There's a number of functions in each one, and then each pipeline has a little stats preview here that shows you how much is going in and out of it, whether it's running into errors, etc. One of the things I immediately jumped on when I saw the product early on when I was a prospective customer is how easy it is to build a pipeline based on sample data. So I can actually capture data from incoming sources anytime, and I can store it as samples. And then I can actually use that sample to help me work through my pipeline or create my pipeline. So I have a sample that I just pulled up. You see the sample data on the right. You see the functions that are in, well, in this case, it's only one function, it's a parser. The functions in my pipeline. And if I click on the Out tab, I'll actually see what this pipeline is doing to that data in real time. The orange just shows me that the raw field was modified in some way, and it's actually multiple ways. If I open it up, I see that a bunch of things have been removed by this because I'm cleaning up filters or I'm cleaning up fields that don't have values, that have null values. I'm also getting rid of redundant headers in this case. So you can see the changes as they occur, which I don't know if you've used some of the other tools that help you do some of these transforms and whatnot. It's a lot of kind of fire and hope, like create the file, put it in place and hope that it works and kind of watch it. I love this because I can actually do it ahead of time. I know what my outcome is going to be before I've ever put it in production, before it's ever touched a piece of my data. Okay, so that's the kind of base set. Now we're going to go over to collectors. I have a collector set up. And if you look at this, you'll see I've got an S3 bucket. It's in the West region. And I've got a path definition. And the path is, this is a templated string that is pulling fields out of effectively the file name, right? S3 doesn't really use a hierarchical structure, but it synthesizes that with key names. So it still uses slashes and it looks like a hierarchical structure. But I can pull this data out. I can pull stuff out from the path to be able to filter on it. So when I wrote this data, when my archival function or route wrote this data, it wrote it using a partitioning scheme that started with the year, the month, the day, the hour, and then the source type of the data, the source zone that it's in, the source IP that the event came from, and then the dest zone and dest IP. Now this one's very specific to firewall traffic. And I will say the partitioning scheme is probably one of the most important things you need to think about to implement this. But these fields here allow me to filter the data as it's coming in. The other thing I just want to note is that with the data collection, you can actually send it to route. So you can send it through as if it's just new data coming into your system like anything else. For our purposes, I actually want it to go to a specific destination. I don't want it to go through the routes. I don't want it to be otherwise processed. So I specify a pipeline. The pass-through pipeline is kind of a standard one that really does nothing to the data. And then I want it output in a Splunk. Now I can use data collection to really preview my data. I can just go up here to this run button and hit preview. If I hit run, I'm going to see the shape of the data that's coming in. I see all my fields. I see it just as if it were coming in. I can also save this as a sample file if I actually want to parse this as I'm pulling it in and I want to create a pipeline for it. Just like I was showing you with the other pipeline, the same thing can be done. But if I'm looking for a specific date, so for example, let's say that back in July, we got an alert that right around the 16th, we saw some potential egress of bad traffic from one of our systems out to a known bad internet system. So let's say we want to actually just go pull data on that one IP address. Oops. And I just want to do it for a couple days. And I'm doing this mostly because this is actually pretty quick, but for a demo, I really don't want you guys just sitting there watching data load for minutes. So I can do a discovery here. And what discovery is going to do is it's going to go look, using my filter, go look through my data resource and find all of the things that it's going to need to ingest. I'm not going to do that right here because it's also part of the full run. So if I run the full run, actually before I do that real quick, I should show you that my Splunk instance in that timeline has no data in it. If I hit run, a job comes up and I can click on that job, I can see the situation. Like I mentioned, discovery happens at the beginning of every job, every full run anyway. And the reason we do discovery is it goes out and finds everything we want to collect and categorizes them as tasks and then feeds them to our job system to go get. So we can scale across all of our workers. If I've got 5 worker systems with 6 or 8 cores each, or 8 CPUs each, I can send tasks to effectively almost every one of those CPUs, barring overhead. So I can highly parallelize this retrieval. And what you see here on the right is the data is already coming back in. We're not quite done. This should take a couple minutes. And oh, sorry, it is done. If I go over here to Splunk, I now have about 2,700 events. Now let's say I continue looking through that. I continue investigation. And I find not only is this system talking to an external system, but it's got a couple internal systems that it's connecting to as well. And you know what? I want to pull the data from those to see if there's any kind of hopping going on or any other kind of problems. So I'll select the same dates again. And again, because I'm using a JavaScript filter, I can actually very cleanly, oh, I get an error right away, great. Let's try that again. Oops, 10.0.2.43. Because I'm using a JavaScript filter, I can do anything, any JavaScript expression that evaluates to a Boolean output. So I can do, if I'm pulling for both of these at once, I can easily do that with an OR statement. So if I pull my run, I look at my job, oops, I look at my job, and same kind of situation. It's going through, it's doing the discovery, breaking it up into tasks, and then it'll start ingesting that data. This one takes took a little bit longer time last time when I tried it, so it'll take a couple minutes. But you'll notice that when we started out with 2,700 records, we're starting to get a lot more. We've doubled up. And if I remember right, this ends up kind of going to triple, around 67 or something like that, 6,700. Which is all great. Easy access to my data. I can pull it back as I need it. As the investigation is taking turns, I can pull data that I need to deal with those turns. It's far more efficient than pulling it off a tape or backups or waiting for anybody to do it. But let's say I've gotten through all this and I realize, oh, wait a minute, I actually want to expand the date because I still don't know when it started, just like in our sample. So let's say I go back to like July, now let's go to July 10th with an end date of the 15th where we started otherwise. And hopefully this cut and paste will work better than the last one, but again, because I'm using JavaScript, I can actually do interesting things like this, where I'm saying, you know what, give me everything where the source IP is one of these IP addresses. So I don't have to do individual ones. I can use kind of the full breadth of JavaScript to be able to do that. And hit full run. And this will do exactly the same thing, continue to do discovery, then pull data back. And what we'll see eventually, and this one takes a little longer, we'll see that the data that I'm getting in Splunk now starts to move to the left. I start to get earlier and earlier data. So really efficient way of getting at my data. I haven't had to involve anybody else. I haven't had to go to other media like tape or anything. And it's all readily available. If I go back to Splunk, we start to see that that data has expanded out. I'm now working on my 4th day. And this will continue to expand as we go on. You guys don't want to just sit here and watch that data flow. So we'll move back. That's the demo. I have a resources page here. We will include these resources link when we send the link to the recording out. Some of these blogs I think are very useful, and I guess that's a little egotistical since I wrote a couple of them for helping you understand how to deal with data collection. But to me, the real key, and to me it's also a real differentiator for us, is sandboxes. Our sandbox environment gives you a full version of Cribble log stream to play with. And each one has a different scenario that you're working through. There's coursework in there you can walk through to learn different aspects of the product. In fact, the log stream fundamentals is really the basic, here's how to use log stream. It gives you kind of the nutshell view of how to use the product. The data collection sandbox is very specifically focused on really just what I just showed you, how to use data collection to get your data and to format it any way you need.